A long time ago, in the land of Anti-Alkene, there was a king named Butane who was very powerful, wise, fair, and kind. But he had no children and was worried that he would not have an heir. He prayed and made carbon offerings to the Orgo gods, but nothing happened. One night, while the king was asleep, a fairy came in a dream and said, "The Orgo gods have received and appreciate your carbon offerings, and hereby grant you your wish to have children. Your queen will give birth to an Alkene. One bond will be your heir, and the other will be the head of your army." The queen gave birth to a Propine and cried as they were banned. You see, a long time before the king was born, Lord Cyclopentine of the Alkene clan ravaged through the land of Anti-Alkene and destroyed all the Alkanes that crossed his path. The leader of the time, Cyclopentane, gathered the remaining Alkanes and decided that no Alkene would step foot on this land again. From that day, anyone that gave birth to an Alkene had to sacrifice their firstborn to turn the Alkene into an Alkane. Seeing the queen's sadness, the king decided to end the ban on Alkenes and change the name of the land to Anti-Alkynes. But not everyone was pleased with the decision, and in turn, Sigma and Pi of the Propine faced lots of bullying. One day, a boy named Hydrogenation told Pi to go away since she was cursed. Struck with guilt, Pi did just that and ran away from her sister. Sigma looked around for hours but had no luck. She decided to go to the O'Malley shop, master of all things organic chemistry, and hoped he would be able to help. "Welcome to the O'Malley shop, where you can buy all things organic chemistry. I just got a new shipment of SN2 reactions. SN2 reactions, which are the best in polar aprotic solvents, occur when you have an electrophile with a good leaving group, such as halides, water, or tosylate. My potions are nucleophiles, which have ions that will substitute the leaving group. You should know that not all nucleophiles have the same strength. Bases are better than acids, so hydroxide will be better than water. The less electronegative, the better. So bromine will be better than fluorine. The bigger the atom, the better. So again, bromine is better than fluorine. And lastly, less steric crowding equals more strength. So diethylamine is better than triethylamine because there are smaller molecules around the lone pair on the nitrogen. An example of an SN2 would be bromopentane reacting with diethylamine. The bromine would leave and the diethylamine will attach to the pentane. You can also remove the H later with reduction. But remember, whenever you have a SN2 reaction, you will have inversion of stereochemistry. "But I'm just a propane that needs to get her sister back and become a propene." "Ah, I have just the thing for you." "Well, first you will need to undergo a radical halogenation since that's the only thing an alkane can do. You can get multiple products from a radical halogenation depending on which carbon the halide attaches to. Possibilities include primary, secondary, and tertiary halides. The least substituted are least likely to form. An example would be a pentane reacting with Br2 and light. In the initiation step, the bromine-bromine bond will break with each bromine attacking an electron and turning into bromine radicals. The first propagation step is the H on the last carbon forming a bond with the bromine radical, leaving you with hydrogen bromide and a pentane radical. The second propagation step is the pentane radical breaking another bromine-bromine bond and forming a bond with one bromine while creating another bromine radical. The termination step is when the bromine radical reacts with another pentane radical to form a bromopentane. In this case, we will only get primary and secondary halides. Since you are only an alkane, you can only undergo a radical halogenation, so take this. It will turn you into 2-bromopropane. What do I do after that? Well, now you need a strong base. Here it is. Oh shoot, this is a weak base. That means you'll undergo an SN1 and E1. These are pretty similar to SN2 and E2 reactions, except the halide will always leave, giving you a plus charge on the carbon that is left. The thing is, the molecule will always rearrange itself to have carbocation stability. Benzylic cations are the most stable, followed by allylic, tertiary, secondary, and primary being the least stable. Here an example of how they occur together. In this reaction, we have 1-bromo, 1-methylcyclohexane. The bromine will leave, giving you a plus charge on the carbon that is left. For SN1, the methanol will attach itself to the carbon with the plus charge now on the oxygen. Another methanol will take away the H attached to the oxygen, leaving you with a methoxy group. For E1, the methanol will take a hydrogen from a beta carbon, resulting in an alkene being produced. Unlike the stereoselective SN2, the SN1 mechanism creates a mixture of stereoisomers. Additionally, SN1 and E1 reactions almost always occur together. Because of this, I think it's better if you undergo an E2 reaction. Follow me here. Now, this is a strong base. E2 reactions use strong bases to turn alkanes into alkenes. Big bases such as terbutyl ether take H's from the non-Zaitsev of beta carbon, while smaller bases like ethoxy groups take H's from the Zaitsev beta carbon. The Zaitsev rule is that the major elimination product is usually that which came from the removal of an H from the beta carbon having fewest H's. The Zaitsev issue does not apply in your case since the beta carbons are equally substituted. And you sure this will get my sister back? Absolutely. Yay, Pi, I found you. Thank you so much, Sigma. Now, you girls have fun and come back whenever you want. I have lots of alkene reactions you can do. Thanks, Dr. O'Malley, but I think right now I want to stay a propene with my sister. The two sisters returned to their castle and learned that Dr. O'Malley can do anything with organic molecules.